Okay, we're going to start talking about an ellipse. So a circle is actually just a specialized ellipse where, everything's equal, where everything's equidistant. So the equation for an ellipse is similar. So the general form looks like ax squared plus cy squared plus dx plus ey plus f equals 0. Now remember we said the circle was all points that are equidistant from the center. So here's the definition for an ellipse. So an ellipse is the set of all points P in a plane, the sum of whose distance from two fixed points, F1 and F2, is constant. Okay, so these two fixed points, the special thing about them, they're called foci. So one way you can think about this is we've got these two fixed points. So each one's called a focus. So this is our first focus, and this is our second one. And we're saying that all the points on, if you pick any point on an ellipse, so if we call this distance 1 the distance to focus 1, and if this is the second focus, D2, we're saying that D1 plus D2 is always the same, is some constant. Okay, so that's kind of like our radius here. Is we're saying that what's not changing is if you take the distance to the one focus, take the distance to the other focus, and add them two together, it's always the same thing. So we're going to start by looking at the equation of an ellipse with the center at the origin. So right now we're just going to be centered at 0, 0, and major and minor axes of length 2a. So I'll explain what the major and minor axes are in just a minute. And we always assume that A is bigger than B here. So the equations we use, and this is for centered at the origin. So this, I'm going to call this a horizontal one. We'll see it's longer horizontally. And this one would be a vertical one. It'll be taller. And C is the length between the center and the focus. Okay, now we have this other really important thing that you need to remember for ellipses, that C squared is always equal to A squared minus B squared. So here we have two ellipses, okay, and this is what I'm calling a horizontal ellipse. And this is what I'm calling a vertical ellipse. Okay, so here we have our center, right? So label all of the points. So first let's say this is the center, which at the moment we're assuming that's at the origin. We'll also learn about how you can translate it to another point on the plane. And then we have our two foci. So this is, we'll call this focus. And this is our other focus. Now everything kind of goes from the center. So here the distance between the center and a focus is C. Okay, so another thing you could say is that the distance between the two foci is 2 times C. Okay? So we're saying this is C and this is C because this is our center over here. And then this is a focus. And this is a focus. Okay, now our major axis is going to be the line that runs through the ellipse that is the longest one. So here, horizontally, this line, here I'll do it in green. This line is our major axis. And for the vertical one, this line is our major axis. I know we've got a lot of terms here. Now, the endpoints of our major axis are called our vertices. Each one is a vertex. So this is a vertex, and this is a vertex. This is a vertex, and this is a vertex. Okay, so the endpoints of our major axis is our vertices. Now, the distance between the center and a vertex, this distance right here, and this distance right here, is A. So remember, C was just the part from the center out to the focus. Okay, so now that's why above we said the length of the major axis, we're going A here plus another A here. The length is 2A. So this right here is an A, and this right here is an A. So whichever one is bigger, you'll see under your X or your Y, you're going to go out horizontally or vertically by A from the center on each sides to get your vertices. Okay? Now, the opposite direction. So for a horizontal ellipse, this would be vertically. I think I have another color. So going up and down, this whole thing in blue, that's called our minor axis. Okay, so each half of our minor axis from the center up here, that's B, which means the whole length of the minor axis is 2B. Now, these don't have a special name, or sometimes they're called different things. So in our book, we call them the endpoints of the minor axis. In other books, you might see them called co-vertices. Okay, so this right here would be B, and this right here. So I know this is, it looks pretty crazy, right? But notice we really have three important things here, A, B, and C. A goes out to our vertices, and that's going to be the longer of A and B, or the longest of all three of them. B goes to our endpoints of our minor axis, which you may see called co-vertices. And then C goes to our focus, okay? And then it's important to remember that you always have the formula that C squared equals A squared minus B squared. So that'll be true for each of these types of ellipses.